Welcome everyone to the red track, aka the best track. Woo! Go front end! Okay, so how the sessions are going to run, every session is going to be 25 minutes, so that's 20 minutes of presentation time and 5 minutes for Q&A. And we have 5 minutes after that if you've got 5 minutes after that to switch tracks or stay in the same session, but you've got to maintain decorum if you want to switch tracks and be there on time so we can do it all in a timely manner for today and finish up on time as well. So the first session here today is actually going to be a double session. It's not going to be a repetition of the same thing. It's just going to go on for the 1 hour, but there'll be a break in the middle. So without further ado, I'm going to kick it off. Woo!
Yeah. Welcome everyone. What a great looking crowd. Look at them, all full of lunch and hope. Can't wait to crush that. Welcome to our talk. Welcome to the red track, like Vanessa said, aka the best track. UI, mobile, collab, they're all the same thing. Might as well put them in the same track. So without further ado, this is our talk. It's called Front End. Started from the bottom, now we're here. For those who don't know, my name is Millie.
And I'm Steve-O.
And we're here today to talk to you, what is this talk about? And, why did you use that dated Drake reference? Well, many reasons, mostly the pun was too good to ignore. But we're going to talk to you today about the front-end landscape in 2018 and why, some of you, a lot of new faces, a lot of junior members in today, but maybe a few older faces, maybe people have come into the industry, a long time ago and seen UI and been like, wow, this shit is frustrating. The tools are immature, the code is young and old. Well, we're here to tell you, like me, no. We're here to tell you that it's actually pretty cool now. Yeah, it's come a long way. And, well, I'm really passionate about this subject. Coming from a design background in university, I thought that coming to REA, everyone would be a UI developer. It would be the best job ever. You write some code, you can see it on the screen. I mean, that's what the best thing about writing code is, right? Turns out that's not the case. Turns out a lot of people actually had a bit of disdain for the UI, for JavaScript, for the web. And, I'm here today to show you that actually maybe it's pretty cool and you should try it. And Steve-O is here as my hype girl and my safety blanket.
I also a bit passionate about the web, and it actually started for me when I was doing my internship at uni. That was the first time I used software where the only interface for it was a website. Before that, I'd been doing Visual Basic UIs and GTK, if any Linux people in the crowd. So then once I realized that UI is you can actually use it for any interface for any software, and it's everywhere because everyone has a browser, I started focusing all my efforts into kind of the web as well. And that's when Millie asked me to help out with the talk.
Asked is a liberal term. I put his name down on the form, and when he got back from holiday, he realized he'd been roped into a talk.
Yeah, I thought I was helping as on the side helping, not in front of everyone.
No, and now you're here, look at that. Yeah. But we want to start out with a massive disclaimer. Hashtag no flame wars, people. We're not here to convince you that JavaScript is better than X or that you should go out and apply for a UI developer role tomorrow. And we also want to acknowledge that front end is quite a broad term. And also means more than just the web, mobile, clients are everywhere these days. But, me and Steve-O, we're web developers, born and bred. So that's what we'll be talking about today. And the most important thing is we're really not big fans of Drake. In fact, I kind of find him a bit insufferable, so apologies.
So this talk is going to be very much a broad, cover lots of areas in a short-ish amount of time, as opposed to going deep into one particular topic. So while we've got a double slot, we've actually broken the talk into kind of 4 sections. These 4 sections are kind of the path that we thought we'd focus on. They're all kind of related to the web rather than the generic titles they've been given there. So while user interfaces might apply to mobile apps, and this track also includes mobile, we're going to focus on the web. So first up is browsers. These things are the heroes of the internet. They're the ones that have started from the early days when the internet was first born to now when they're fully powered Chrome browser that does a billion different things. And they've been battling for performance and feature enhancements for many years. If you actually look at Wikipedia for the browser wars, there's actually a log of all the wars that they've been fighting, from Netscape versus IE to Chrome versus Firefox. It's actually quite a good read if you're into that.
Which I am,
Yes.
always.
I thought you would be, Millie. So they've come a long way. I couldn't actually find any really good stats to compare between old browsers and new browsers. A lot of the stats are comparing Firefox versus Chrome, that sort of thing. This is one I could find from Chrome version 2 to Chrome version 21. We're at 50, 60 something, whatever it is. But I think it's just because everyone knows the differences fairly intuitively. If you've used IE6 and you've used the latest Chrome, it's a pretty stark difference. If you look at the old IE browsers, they were pretty much just document renderers. They wouldn't actually render transparency in PNGs. They were really slow at executing JavaScript, but their main purpose was just to show a document. You look at a new Chrome browser, they've got really fast, just-in-time compilers for their JavaScript, and every tab on there is a separate process. So they've come a long way. And all the features that they've been fighting over, so performance is one thing, but features is the other part they've been fighting over. Some of which you probably already know, like local storage or IndexedDB. If you use Google Maps and you click the little Where Am I button, it shows you your geolocation as long as you allow it. And there's input fields. If you go to something that's expecting a number on your phone, it'll show the numeric keyboard as opposed to the QWERTY keyboard. You're probably familiar with those. But there are a whole bunch of other features you may not be familiar with. For example, you can use websites that have offline first capabilities, where once you've actually browsed to it once, the whole thing works offline. You can get push notifications. There's background processes through Service Worker and Web Workers. There's browser windowless applications as well. So once you've added your website to your home screen, next time you launch it, the Chrome part of the browser is not there anymore. It just looks like a native app. You can even access sensors like the gyroscope, the proximity sensor, and the compass, and you can even do virtual reality and web Bluetooth and USB, all from a modern browser. But there are so many browsers, and they all have different support levels. So how do you make use of these kind of or these new features if they're not actually in all the browsers?
How do we do that, Steve-O?
Let me explain.
Oh.
So there's this term thrown around called progressive enhancement. What that means is that the core functionality of your website is going to be to display data. It's most likely telling a story of some sort, and displaying text, every browser can do, even the command line ones. But with progressive enhancement as the main goal, you can start off with that really basic premise of displaying information and pictures, but then if your browser supports these modern features like web USB and Bluetooth, you can progressively enhance the website to make use of those things, and that way you kind of support all cases. But this isn't always important, so for apps at REA, you're probably going to want to keep this kind of mindset in mind. But there are also hobby apps. I kind of use hobby apps as a way of practicing.
No way.
Yeah, you might have heard of some.
Yeah, maybe so.
Yeah, maybe. But either way, it's a really good way of practicing. And for those situations, don't worry about progressive enhancement. You can just pretty much go nuts and use all the latest cool toys. A really good example of this is actually Nick, who's in the audience. Hi, Nick.
Hey, Nick. What's up?
At the UI Guilds, Nick gave a talk about a drone lap timer, so for racing drones. And he used web voice recognition, so you could actually say start the timer and the timer starts. Speech synthesis, so when the drone went through another lap, it would actually announce your lap time. There was web Bluetooth for detecting the nearby drones, and WebSockets for updating the UI in real time. So with all these features available to you, how do you know which ones you need to support for the progressive enhancement steps? Well, we have this website called caniuse.com. It is the bread and butter for a web developer. If you want to know if you can use web USB, for example, you can search for it in Can I Use Web USB? This example is of Service Worker, and you get this nice little graph of which browsers support which features. Very handy to kind of use as a tool in our day-to-day. We actually couple this with our Omniture stats. So if we know 80% of our users are using a modern browser that supports Service Worker, for example, it might be something we can use in the future. But there's another situation where you don't have to worry about browser compatibility. This might sound a little silly, like instead of making it work on all browsers, you just ship your own browser with your app.
That does sound silly, Steve.
It's really helping. If you've used any of these apps, which you probably use Slack at work, or maybe VS Code or Atom, these are actually websites wrapped up with a Chrome browser and packaged as a native Mac app or a Windows app. So this is done through a project called Electron.js. And on their website, it's not just these kind of popular apps, but they've literally got hundreds of these apps. So if you're looking to get into web development and you want to make a native experience, then WebTech can still help you. And the APIs that are provided by Chrome is pretty full-featured. So Stuff like VS Code has become pretty popular, and Slack, as you know, as well. The other big concern that a lot of people have when trying web development for the first time is animations. They think when I look at my iPhone app, there's these really smooth, buttery animations. They look all really nice. And then when you see a really crappy animation on the web, you think, oh, well, web, it just isn't capable of those sorts of things. But it turns out it is. This is a little demonstration of a website called Anime.js. It's a tool for making animations. And the animation on their homepage, that was their homepage there, is pretty nice. And even when you click in there, you actually get the little firework display. I can play that video again if I can find my mouse. There it is.
Good job, Steve.
Thanks. So that's running at 60 frames per second. And when I click around in that website, you'll see these little kind of interactive animations like that. So those things are actually accelerated by the GPU. But by default, if you were to just think, oh, I want to animate something, so I'm just going to write a JavaScript loop, and I'm going to get the X position, and I'm going to increment that X position on every iteration of my loop, you're probably going to end up with a pretty terrible animation. And that's because those operations are not really designed for animations as such. They're kind of just done on your CPU, and every time you do one of those things, it causes the browser to relay out the whole page, which is not going to give you 60 frames per second. However, there are some guidelines to achieve this. So the main one is using a tool called CSS transforms. These things include scale, rotation, translation, and skew. You get a CSS API for that. You can also affect opacity, and all those operations will be handled by your GPU instead of your CPU. Now that's through CSS, but you're thinking, well, I probably want to use JavaScript for some of those things, and you can. There are functions called Translate 3D and Matrix 3D that allow you to use those same CSS transformations from JavaScript world. There's also a technique called flip, which I won't go into detail now, but if you want to look it up in your own time, it basically gives you a structure for writing your JavaScript in such a way where you don't block the browser's rendering pipeline. But CSS animations have some problems. They don't allow you to have fine-grained control over how the animation works. So for example, if you wanted to animate a bunch of different things and orchestrate them in a timeline, you might have a bit of a hard time doing that with CSS transitions. However, there are libraries like Anime.js, which is that website there, and GreenSock that allow you to do this. And JavaScript by itself offers a few low-level functions, one called request animation frame, which will allow you to kind of fit into the rendering pipeline of JavaScript. There's also high-level APIs, like in the latest Chrome, there's an experimental animation API, which kind of takes care of a lot of these good practices for you. And then the libraries like GreenSock and Anime, like I mentioned, do all this sort of stuff for you as well. Millie and I used a bit of GreenSock in a little hobby project of ours, drag and drop cards.
You might have heard of it before.
Maybe. You should check it out. There's also a person on the internet called Sarah Drasner. She's worked for Microsoft. She has incredible videos on animations. Just Google her name, and she's got SVG specific ones and just animating in general. They're really good. So this brings me to another thing. It's like web developers, you'll kind of hear this term thrown around every now and then where the browser is the operating system. Now clearly it's not the operating system, but from a web developer's perspective, it's almost as low a level of abstraction as we need. If you think about iOS and Android, they both provide core functionality and APIs for you to get access to sensors and things like that, and the browser does the same thing. But with a browser, they're actually on Android and iOS and Linux and Windows and Mac. So the user base is actually way bigger. The browsers expose APIs for pretty much the language itself, but also all the browser features. And the language that is used, the JavaScript language, is driven by a community around a standards body, and it's kind of like choosing the direction of this stuff, getting the community involved in picking what should be included as a standard and what should just be an external library. It works just about every platform, and they use a single set of technologies, so just JavaScript, CSS, and HTML. So to compare the browsers and other traditional operating systems, just for the sake of that sort of statement, if you look at an operating system, you get a terminal. That's kind of like the basis of the operating system, and the browser has a JavaScript console, as long as you're not using an old browser which doesn't have one of those.
I wonder which one that is.
Yeah, the one we all love. So operating systems normally provide a way of providing graphics, so think Windows. HTML and CSS are our user interface tools. All operating systems probably work offline. There's not many that require an internet connection to work. You'd think browsers do, but with application cache and service worker, a lot of your websites will work offline as well. So that kind of, it parallels your operating system too. They run applications. For us, those applications are websites. You browse to a website and you're executing a ton of code that wasn't originally in your operating system. That and browser plugins, which have a little more privileges than normal websites do. They manage processes, and every browser tab, as I mentioned earlier with Chrome, is its own process. And with web workers and service workers, you now run off the main thread as well, which kind of is really good for heavily computational tasks like cryptography or even in some cases animation things.
Bitcoin mining.
Bitcoin mining. So disk.io, with an operating system, you generally have access to a file system. In a browser, you typically don't, but there is local storage and session storage, which allows you to write key value pairs to the user's browser. There was always cookies, but they're kind of limited in use. IndexedDB is a full-blown database that you can do queries, and it can store a lot of information. And modern browsers even have an API to access the file system of the user. So if you were using the Chrome DevTools, you'll see the same sort of thing that pops up and asks you for permission to the file system. Network I/O, when browsers got AJAX, you can now do asynchronous network calls, just like an operating system could. And with WebSockets, you can now do bidirectional communication as well. Peripherals, so there's a mouse and touch APIs. There's obviously keyboard ones as well with key presses. And now with Web USB and Bluetooth, you could even interact with a gamepad or a VR headset. And a firewall. So when you did the where's my location on Google Maps thing, it would normally ask you, do you want to allow this site to get access to your location? That sort of functionality applies to getting access to the microphone and the webcam and all those things as well, built into the browser. And if you want to go down the sort of protecting yourself against cross-site vulnerabilities, the browsers nowadays have a lot of things in here. I won't go into detail with sort of the rest of these protocols, but it's another homework task for you. So now that we know what browsers are all about, if you want to write code for them, I'm going to pass you over to Millie, who's going to explain JavaScript.
Cool. Can anyone really explain JavaScript? I don't know. So we've learned about the browser and it's kind of our environment to run around our playground, but how do we actually do shit? How do we utilize all those amazing browser functionalities that Steve-O was talking about? Well, let me tell you. Actually, no, let's take a step back. So me and Steve-O, we did a survey recently. We sent it out to a myriad of developers, both who identify as front-end and back-end. This was in the Functional Programming Guild and the UI Guild. And we asked a couple of questions. You know, what do you think the role UI developer is? You know, have you used React before? What do you think of CSS? And we got a lot of interesting responses back. But the one question that had the most hilarious responses was this one. What do you think of JavaScript? And I love these answers, and it ranges from, you know, it's a problem to Batman JavaScript. But I want to highlight one answer, and that is the last one. It was created by Satan. So let's talk about JavaScript. Or, you know, Satan, whatever you prefer. So we've all been tripped up by JavaScript before, and I can understand these answers, and I'm right there with you. When I was first learning JavaScript, it was a nightmare. And that's because JavaScript is a unique beast. You know, and some of that comes down to the fact that it was created in about 10 days, you know, by a handful of people, and it was meant to be used as a short-term thing to get features out into the web. Well, you know, however, 20 years later, we're still using it. And that's because there are some things that only apply to JavaScript that aren't really around in other places. For instance, this. You know, what the fuck is this? Literally. If I define a variable in this, depending on where I call it, it'll either be on the window, it'll be on a function, it'll be in a class. Oh my God, who knows where it's going to be? Who knows where it's going to end up? It might just bite you in the ass. And it's pretty easy language to abuse. So there are things like prototypes, and that essentially is the origin object for that primitive type. So for instance, an array, and this is a cool story, there was a framework called MooTools, which back in the day was essentially jQuery, and MooTools were like the shit. And they were ahead of their time. They thought, you know, if I have an array of arrays, or for non-technical people in the audience, if I have a list full of lists, wouldn't it be great if I could just make that one list? And that's pretty standard, right? Lots of other languages had that. So they said, we'll write our own method, we'll call it flatten, and it'll be great, and everyone rejoiced. Fast forward 8 years later, and you know, the JavaScript governing body said, you know, we'll have our own flatten list, and it'll be great. We're going to do it slightly differently. And turns out they broke a lot of really old websites. Whoops. So this German weather site was like, oh shit, this is broken. I should file a complaint to Firefox. And the JavaScript community reacted with panache and grace as usual and said, what the hell, man? Why can't we have nice new things if we have to support all these old websites? And along came one user who said, look, we can have it both ways. Let's just call it smush. Let's call it array.smush, and it'll be great. And there were bunnies and everyone was happy. Not really. Everyone was like, that's dumb. I think in the end they called it flat and caved into peer pressure, but I really wish it was called smush. Fast forward 2018, JavaScript is actually pretty aight now. It's actually a lovely modern language and has a lot of features that you'd use in any other language used today. So I'm going to take you through a few of them, such as, arrow functions. Basically, we can all use that lovely fat arrow that you've seen in many other languages, and the main benefit of this is basically less code, less lines of code. So you've probably written a function like the top one, function, name, taken my parameters, and this long ternary statement. Well, I pretty much smushed that into one line. And as you know, Steve-O, less lines of code means less bugs. Classes, they're a thing now. Yeah, I bet you didn't know that. So classes in JavaScript, they look like your typical OO classes. They're different in subtle ways, and they're essentially just functions under the hood. But you can use them just like you would use any other class in any other language. In fact, I've created a new class, Prezzo, and I've created a new object with the new keyword, and I've inserted some parameters based on the constructor. It's pretty sweet. So fun. Async, yes. So a lot of people, perhaps who don't know what this word means, it just means doing things out of order. And maybe some old JavaScript developers would be cringing in horror and say, merely async, I think you mean callback hell. And if you've seen code like this, I sincerely fear for your mortal soul. But this is how we had to do asynchronicity in the past with JavaScript, essentially callback functions. And what that means is it's a function that calls another function to let it know when you're done. So it's essentially, you could end up with nested functions within functions within functions with, oh my God, there's so many functions, and they're all calling each other. Oh, Jesus. Well, now we have promises. And I promise you this, these are a lot easier to use. Thank you for that pity laugh. So essentially, promises are when I want to make an external call, as in something outside of my own code base, I need to know whether or not that request has been successful. And that's not always guaranteed. Networks slow, they're flaky, who knows what's going to happen. An elephant fell on a data center somewhere. So we've said, hey, if this was successful, do a thing. If it wasn't, just throw an error. No one will really care. So we're essentially taking some data and we're mapping over that, assuming that it was successful, like a functor. That's for you, Stilly, in the back. But Millie, you're saying the types. I can't jump over the types. And it's true. JavaScript will never be a statically typed language. And for some of you, that is a deal breaker. Well, we have some presents for you. So there are actually libraries, frameworks, and tools to help you. In fact, we use Flow in my team at REA, and it's almost like a linter that will ensure that you have your types properly done. And TypeScript essentially is what's called a superset of JavaScript that will compile to JavaScript, which is a bit strange in my opinion, but it's like types from the ground up. And if you're really hardcore, you can go FP from the bottom. And that's a language called Elm on the left, which will compile to JavaScript. And if you just want another library that does types, you can use Ramda on the right. So now that we've gone through how to do shit, we've got to make it pretty. And that's one of our favorite things is writing CSS. But before I hand over to Steve-O, I have to tell you that part one of our session is ending. And if you want to move to another session, you're very welcome. But I will call you out as soon as you stand up and shame you in front of the whole audience. So choose wisely. Perfect timing.
Guys, what a cliffhanger. You do have 5 minutes to go to the toilet or do whatever you want. Don't maintain decorum. Don't run over anyone. Come back. No, maintain decorum. Don't run over anyone.
Oh, yeah, guys. You have to wait a bit.
Oh, do we?
We're going to keep going.
Do we have to wait?
Oh, you can do whatever you want.
Okay.
Well, how do you mean?
Do you have to wait 5 minutes?
Yeah. We're definitely 5 minutes, yeah.
Oh.
Yeah. I'll let you know when you.
Oh, okay.
Yeah. How do you mean? Yeah.
Sorry, I thought we just would say, hey, you can go if you want, and then keep going.
No. We'll wait for 5 minutes. Take a break.
Okay.
You might have to
Speed up.
Yeah.
Yeah. Because last time
No,
we
I'll
were
get
at this
this
point.
Yeah. Yeah. Last time we were at BEM, and then last time we were at
Yeah.
CSS.
It was really good. It was
Yeah.
like, yeah.
Yeah, we're a bit behind schedule.
Yeah, we're going to slow.
It's,
That's all right. That's fine. I
might
trust
have-
you'll make up for it.
We might just end up having 5 minutes for questions instead of 10.
It was going to be fun with questions anyway.
Oh, okay.
Yeah.
It should be fun.
okay, cool.
That's right. They turned off my microphone instead.
Cool.
Should we do some like mid-talk feedback?
Feedback,
Yeah.
like on the talk or
Yeah.
like survey.
Just be like, how you feeling?
Okay.
Hey guys, we're going to do something unconventional. I'm going to ask for some mid-talk feedback. That's pretty agile. So how do you think we're doing? Are we going slow enough, fast enough? Is it? Don't give me that, Steely. Anything you think we could improve? Just shout it out, or give me a wink. I don't know. I'm getting thumbs up, so I take that as a good thing. Thanks, Anwesha. Yeah, more heckle, please. I'm going to have to heckle Steve-O all by myself.
Just start heckling after my next section.
Oh, it might be coming up at the end just for you, Anwesha. Just for you. And I will post it to all the relevant social medias afterwards. It took a long time for me to make this.
Oh, yeah.
We're so cute. Hey, Tom. You're just in time for the best half of the talk. It's not. We've already peaked.
Speed run.
Speed run. Yeah.
That's now one good to go.
Sorry, we should have organised some Drake. I can play it like next to my microphone. Will that work?
Started,
No, that's how the song starts.
started from the bottom, now we're here. Started from the bottom, now my whole team fucking here. Started from the bottom, now we're here.
User interfaces. All right. For those of you who've just joined, we're just waiting the required 5 minutes for everyone to settle before we continue our part 2 of the talk. Something JavaScript, something browsers, otherwise
45 seconds.
Drake. Me heckling Steve-O a lot. Who said yes?
So if you've missed the first session, it'll be online at a later date.
We will have a screening in PSW for our talk. Alyssa? Why are you at the back?
Should we mix that?
Yeah.
Yeah. Welcome back after the break. Hope you've all got refreshed from the 30-second break we had. So our next topic is user interfaces, and for that we've got HTML and CSS. How many people love HTML and CSS?
Woo!
Oh, that's surprising. That's really good.
Tim loves it.
So HTML and CSS, what are they actually for? This screenshot here is the first web page ever. So that little line at the top there says, the World Wide Web, or W3, is a wide area hypermedia information initiative aiming to give universal access to a large universe of documents. So HTML is really just for displaying documents. CSS is kind of the thing that allow you to change the colors and stuff, but it's really just for documents. However, if you fast forward to today, things like Facebook, they're no longer a document anymore. Like we're well past that. But those sort of asynchronous advanced web applications were really not foreseen at the point where the internet was made. So this website here is called CSS Zen Garden. Who knows of this site? Yeah, quite a few. So for those that don't, this was made back in the day to demonstrate that if you have a single HTML page or a single document, you can style it with CSS any number of different ways. So every one of those little flashing versions of this site is the same HTML, but a different style sheet. And on their website, they've got 218 of these things, users submitted. And then in the fine print there, there's actually another 1,039 that didn't make the cut. But it gives a nice idea that separating your styles from your HTML was back then especially a really good idea. However, if you look at the sort of Facebook thing, you're probably not going to want that. You're probably not going to want to style the document, which is actually the web application, different for different documents. It just doesn't really make much sense these days. But that's what CSS was really for. So if you think CSS can do all these amazing things, why do people hate it so much? The main reason is because everything in CSS is global. Every line you write is essentially a global variable. You can do things like nesting, so you can have these rules only apply if they're nested under this other thing, but that gets a bit unwieldy the bigger the site gets. And also the more you do that, the more performance of a hit you take as well. So this CSS global namespace has been the biggest problem. There have been a whole bunch of solutions to this though. The first notable one is BEM. For those of you who don't know BEM, it's basically an acronym for Block Element Modifier, and all it is a namespacing convention. So it doesn't have, you don't have to install BEM, it's just a convention that you and your team agree upon. So given some markup like that I've got in the corner there, that's an anchor tag, and it's got two spans inside of it. So the surrounding anchor tag has actually got sub-components, if you want to think of it that way. When we style this thing, BEM says just use class names. Don't use anything else, just class names, and use the class names to follow convention. The first convention is, the very first class you div is the name of the block. So in this case, the block is this whole link anchor thing, and we're calling it a button because we kind of want it to look like a button. The next set of rules is separated with these little underscore things, and that represents the internal elements of that thing. But you'll notice that it actually has prefixed the component name as well, so this is all part of the convention. The next block is the modifiers with the dash dash. This basically allows you to specify all the variations of that thing, like the orange version or the bigger version. They go in a separate kind of set of rules. When you have this sort of setup, we're just using class names, and this actually gets around a lot of the problems because if everyone follows these conventions, chances are you're not going to have a namespace clash with another component. In this case, though, button is pretty generic, so probably not the best example. But it's still showing how you do namespacing. The reason they only chose classes, though, like why would you only use class names when you can use IDs and elements and all these other things?
Why would they do that, Steve-O?
That's because CSS specificity, Melanie. That's a hard word to say, but basically it means that when you define a rule, depending on how you define it, it has a precedence. It's kind of like the order of operations in maths. So in this example, I've got a heading and it's red. And the reason it's red is because if you look in that little style tag at the top there, there is a H1 with color red with bang important on the end. That takes precedence at all costs. That is the hardest amount of override you can give that rule. If we were to get rid of that rule though, then it falls down to the inline styles there. So that style attribute on the H1. So now it becomes orange. If we get rid of that rule, then it falls back to the ID rule. Get rid of that, it falls back to the class name rule. Get rid of that, and it falls down to just the element specifier. Get rid of that, and we get the browser default. So this sort of order of operations really matters. And the reason BEM picked class names is because they felt it was the perfect balance. If you have too little, like just element specifiers, it affects everything on the page by default, kind of making that global variable problem worse. If you have something like important everywhere, then no one can ever change that style. Like that is a really strong thing, like a hard thing to override. So anyway, that was the first kind of way of solving the global problem. But the industry's kind of moved on a bit there, and CSS Modules was kind of the next big change in this world, which is kind of cool because it was founded by a couple of guys in Melbourne. There's a whole bunch of contributors, but Mark Dalgleish and Glenn Madden, they run the UI Guild here in Melbourne as well, or Mark does. They really pioneered this. They asked the question, what if all your rules in your CSS were not global by default, but they were all local by default? So how would you do that? Well, imagine you've got these styles here. Now that red class name is pretty generic, and that could be rea-red or like some other red. So we don't really want to expose that to the browser. So assume we're writing React, and we want to say we just want the red style from our style sheet. There I've kind of used styles.red. But hang on a sec, how is that even working?
How is that working, Steve-O?
That's from the magic of Webpack.
Whoa.
So what is Webpack? You may not be aware. There's this concept of a bundler. What a bundler is going to do is kind of troll through your JavaScript code and follow those import statements. So every time you import another JavaScript file, Webpack is going to go to that file, follow the import statements in there, go to that file, concatenate them all together, minify them for a production bundle of JavaScript, and it can also do things along the way, like pre-processing. If you wanted to write one file in CoffeeScript or ES6 and you want it all compiled down to ES5, Webpack can do that as well. But in this example, we're actually importing from a CSS sheet. How does that work? Well, what CSS Modules does here is it kind of instructs Webpack to parse the CSS and then get the class name that you're using and then generate a randomly kind of generated globally unique version of that class name. And then when you import it, you get that little commented out JavaScript object there that says that red that you're after is actually this auto-generated thing. And that means we never have to expose the class name red to the browser, which means we get around the global variable problem yet again. So this is what the resulting output looks like. Red is not exposed. This styles __ red _ some number is exposed, and that has your rule in it. Then the next evolution of that is kind of the latest movement, which has still got a lot of churn happening right now, called CSS and JS. And they ask the question, why do we even need CSS at all? If we're looking at React, you've got your JavaScript files, and the JSX in there is essentially HTML. But yet we still have CSS off to the side. What if we sliced all our stuff down based on a component rather than based on a technology? Because React kind of does half the problem there. So CSS and JS, as I said, there's still a lot of churn. There's a lot of different solutions in this space. But one of the most popular ones is style components. And there's quite a few code bases that are using this now. They basically define styles inside your JavaScript. So there's no CSS file at all. And you'll notice there's not even a class name here. Just like before, class names are just a way for the developer to refer to the styles they want. Here, if the styles are built into the component, you don't even need to refer to it. You don't need a class name at all. We actually get away from the specificity problems too. But what this actually means is that we're throwing the cascade away. So now we're not defining CSS files, we're not defining class names, we're just using CSS just as rules. So with this, we get the same sort of concept as CSS modules, where we get auto-generated class names. It becomes an implementation detail. And now we're using JavaScript for everything. And that's kind of a better choice, because globals by default in CSS is not the case in JavaScript. JavaScript has a full programming language behind it. We can do whatever we like, pretty much. And you can do these optimizations at compile time. If you have 10 rules all defining the color red, potentially we could extract that out to a single rule just for that part and mix and match with other predetermined optimized versions of the CSS as well. So we started with cascading style sheets as CSS, but we've kind of gotten rid of the separated sheets part and we've kind of gotten rid of the cascade part. So really we're just left with the style and we just add it straight to the components. But if we're doing this, how do we inherit stuff? If we're throwing away the cascade, how do we reuse our styles across many places? Well, React has already given us a really good pattern for this, and that's component composition. So if you can compose different React components for a single purpose, that same concept applies for styles. Another big bugbear for CSS, why a lot of people hate it, is because they've probably had to do layouts in CSS and make them work across all browsers. And if the words floats, clear fixes, or table layouts kind of like makes you nervous.
They do make me nervous, Steve-O.
I can tell you're sweating. Websites don't have to look the same in all browsers anymore these days. We've kind of trained users now. If you go to a website on your mobile device, you're expecting it to look different than it does on your desktop. So why do we have this rule then in our teams where it's like, it must look the same in every single browser? Because of this training we've done to the users over the years, if you've ever looked at Wikipedia, if you look at the desktop side of Wikipedia, it looks pretty ugly. It's a bit dated. If you look at the mobile view of Wikipedia on your desktop screen, it looks much nicer. Next time you're on Wikipedia, scroll right to the bottom and click mobile view. You'll probably want to leave it on that for a while. It's pretty good. So if you want to do layouts today, we've got Flexbox and we've got CSS Grid. Now, they don't have support in all the browsers. But with this mobile-first approach, where you get a nice, simple, most likely single-column view of your page, that can be your default. Just like Wikipedia, they didn't bother making sort of really advanced desktop layout. They just used the mobile one to start with, and then you can progressively enhance. So imagine you've got your website as a single column, and then if you have CSS Grid or if you have Flexbox, you get a nicer version on the desktop. There's a really good video on this. If you Google CSS Grid, this changes everything. The video is really good. That's where I got the Wikipedia reference from as well. So we've kind of spoken about how Webpack can do this magic of following your imports and even do things with CSS. It can even import images, but they offer a few other things as well. So CSS, so Flexbox has a few variations across the browsers. Specifically, IE9 is slightly different, but a tool like Webpack can fix that at compile time by auto-prefixing your rules to work in slightly different ways for different browsers. You can do transpiling and polyfill things like fetch that Millie mentioned earlier. Not all browsers have fetch, but the latest Chrome does, but stuff like this can polyfill that. And that leads us to the next section of tooling.
Thanks, Steve-O. That's a great segue, because, you know, some people would describe me as a tool. Cool. So tooling really helps. And, you know, someone in the keynote this morning mentioned developer experience, and it really is a massive thing. Like, I'm going to enjoy writing JavaScript if it's easy to do. And if it's easy to get my website onto the web, I'm just going to be a happy Larry. So some would say tooling, it's really hot right now, especially in UI and front end. It seems like every day there's a new tool or a new thing coming out that everyone's clamoring about. So I'm going to take you through some, because there are many. And we're going to start with debugging, because back in the day, you were lucky if your IE browser had a JavaScript console. Well, now I'm just going to froth a bit about Chrome DevTools, because it is amazing, and you'd be surprised at how many features it actually has. So one of the things you can go through, you can write code into the Chrome DevTools. It's essentially an IDE. So one of the really cool audit tools is called Lighthouse. And what it does is it will actually test your website and give you a score out of 100 for stuff like performance and accessibility, SEO. And here's a little example I prepared earlier for an amazing website called dragandropcards.com, which actually gets a pretty good rating. And we use this at REA right now to test accessibility. I see Sarah's in the audience. We use this a lot to test how good our app is. And if it's a little bit shit sometimes, it'll give you meaningful links and data on how to actually improve that. You know, Chrome wants your websites to be good. So let's take a bit of a segue into the server. Now, the server, it's a thing now. Did you know that, Steve-O?
Yes.
Yeah, well, in 2009, this guy doesn't know anything. In 2009, a guy called Ryan Dahl invented something called Node.js. And essentially, this means you can write JavaScript on the server now. Hey! It means you can write nothing but JavaScript for your entire life, and it will go on everything. And I know some of you are rejoicing at that, but, you know, for some people, they thought, wow, this is an amazing, you know, enhancement. What would happen if we ran our web apps on the server and the browser? Thank you. That's right, Steve-O. It's isomorphic, bitches. Now, Millie, I hear you saying, what the fuck does isomorphic even mean? Well, no one calls it isomorphic anymore, that's for sure. We call it universal. So it basically means that you can run your website on the server and the browser. And I'm going to take you a bit of a journey, shall I say, on why this is good and why the fuck do we even want to do this. Strap in, Steve-O. So in the beginning, everything was run on the server. You know, your server pre-rendered your entire website and handed it to the browser, all prettied up and packaged, and said, you know, don't worry about it, browser. You can be as dumb as you like. I'm going to give you this website, and all you have to do is render it on your pretty little face. And the browser was like, yay! But that meant every time you went to a new page, that server had to do all the work. It was adding you pages by page, and if you clicked on a lot of pages at once, it was like, oh God, okay, here you go. And this is like your classic web apps. You know, this is your WordPress, your Drupal, and it's actually how a lot of websites ran back in the day. So what would happen if your server was under a lot of strain, or it was, you know, the network was slow or something like that? Your browser's stuck waiting for that web page to arrive. It's like, hello, I'm waiting here, and the user's getting pissed off. And imagine you're filling out a form, and you've written all your things, and then suddenly you refresh. Well, bam, that data's gone. Whoops, sorry about that. And then with the enhancement of browsers that Steve-O was talking about, then came the single-page apps. And these were awesome. You know, basically the browser had power and was smart. the server would say, here, have a web page, it's a bit of an empty box. And the browser's like, all right, okay, cool. I'll take that, and what am I supposed to do with this empty web page? Well, here's your 5 megabyte assembly instructions. Enjoy. And the browser's like, wow, that's a lot of JavaScript I have to read. I better get going. All right. So in the end, it was great once that JavaScript was loaded. But in the meantime, that user is like, wow, this time to first paint is taking a while. No one actually says that, except developers. But the user was like, this website's taking a lot of time to load. And Google, at the time, didn't know how to read JavaScript. It was like, the fuck am I looking at? I ain't going to rank you. And it didn't, that's for sure. So what if we could combine them both? Well, thank you. With the advent of Node, we now can do the best of both worlds. So the server and browser work together. The server will pre-render the page, just like in example 1, and hand it off to the browser. Nicely laid out all. And the browser will take that web page and fill out kind of the front, more the real to the glass concerns. So that's stuff like the window and document. And in React, we call this component did mount. And I'll make it a bit spiffy. I'll rehydrate the page, as we say in UI. And this made a great user experience because not only was it fast to load because it was pre-rendered on the server, but once it was there, the browser's like, nah, I got this. Every time I go to a new page, it's all within the same app. It's quick, it's snazzy, and it feels like a native app. Oh my God. So now we're going to try a little bit of a interactive. I thought more people would be on their laptops, and I'm actually glad to see that no one is, so this is great. But this is something that you can take home, like in a doggy bag, like a little take-home present for you. We're going to make a website, and it's going to take 30 seconds. So there's a great tool called Create React App, and it's a really cool way to get up and running, making your own website in about 30 seconds to a minute, depending on how long it takes you to download all the dependencies. So install Yarn, install NPM, they're basically the same thing these days. Install Create React App, and make a project. And then when I run yarn start, which is a command on the terminal, I'm going to get a website. Oh, holy shit, there it is. Oh, there it was. And we're going to take you through a bit of what that boilerplate actually looks like. And if you're looking at this and saying, really, I don't know what I'm looking at, there's a lot of things, well, you don't need to worry about most of them. We're going to dive straight into app.js. This is where your web page is. And if you've never seen React before, maybe this is a bit scary, but I'm pretty sure you've seen HTML before, and for all intents and purposes, it is HTML. Don't worry about it. And we're gonna create a button component. We're gonna do it right live on stage, pretty much. This is a screenshot, but don't worry about it. So a lot of people are scared off by React, and they're like, I don't know what this component business is. The syntax is all weird. There's squiggly brackets. Well, a component or anything is basically just a function. I've defined a function called button with a capital letter because conventions, and I'm passing in props as a parameter. And then I'm actually using them. So when I've defined button down the bottom, I passed in title props. Oh my God, more props. And this is how we access them. Oh my God, that's how we use them. It's just that easy. It's nothing, there's no magic here. They're just functions and JavaScript. It's so reusable. So the syntax might be specific to React, but the underlying concepts are all, they're just good engineering. So stuff like reusable components, single responsibility components, removing the view from the business logic. That sounds like a backend app, Steve-O. Oh, I've tricked you all. This is a backend talk. So in conclusion, why should you care? We gave a bit of a long talk, and maybe some of you are sitting there thinking, why is this relevant to me, or why should I care? I don't actually use JavaScript in my day-to-day life. Well, the language is not important. It's more the idea that hopefully we've shone a light on some of the scary parts of the UI, and why they're not actually scary. They're actually a really exciting place to be, and how some of the things that were frustrating in the past are now really simple. So I'm not telling you to go out tomorrow and write all your apps in JavaScript, although JavaScript, HTML, and CSS are the most popular technologies on the web, and apparently according to Stack Overflow, in the world. If I go out and, in a couple of weeks is rea.io, I'm probably not going to break out the Scala to do a little prototype app. It's pretty easy to do with just JavaScript. And in fact, we want to arm you with the knowledge to be able to create things quickly and explore the web and all the wonderful technologies using some of the new tools. So, if anything, we hope this is a little bit less scary environment for you. And hopefully people, like Stilly, will not give the UI so much shit. Any questions? No? Yes?
What was that?
The default browser text. Is it what?
Is it black? Yeah. Sure. I don't know.
Don't worry about it, he's trolling.
So speaking of IDEs, I understand being able to execute stuff in the console once the page is loaded and test it out and using it as a debugger, but I shouldn't ask you because you'll just say VI, but is there some consensus across UI devs, even in REA or just in general, about what the best editor is?
Yeah, don't you answer this question.
Even one that closely resembles IDEA for Java or Scala editing.
Microphone or a can of worms?
Yeah.
I was going to wear my Vim t-shirt. But I decided not to. There are a few actually. So WebStorm got a lot of popularity, even at REA. I think I saw a lot of people doing that. But I think the best part of the tooling is actually the command line tools. So like things that you install with NPM are probably going to offer the majority of them. And a lot of the wrappers now are just wrappers around those things. So not those wrappers. Like VS Code is incredibly popular, and it just wraps like linters and all that sort of stuff that are command line tools. So I think it kind of opens it up to whatever your preference is. But I think VS Code and probably WebStorm are probably the two that come to mind.
And Vim.
And Vim.
But I guess you can use Chrome DevTools as your editor. I've never actually seen anyone do this in the wild, but you can open your project if you give it permission to your file storage system and open it and make live changes and see those in the browser. So potentially something to look out for if they ever do enhance that down the tool, but then Google
There's
has
some
all
nice
the data.
demos of it actually, because if you do link up a workspace in Chrome DevTools, the minute you make a change and press enter, your live reload server kicks it in and it all refreshes, and it's actually quite quick feedback.
Good question, Tom. Is it actually a microphone?
Yeah.
Oh,
That's
okay.
very.
Just throw it at someone.
Anyone? Just talk. They have to ask.
Then they have to ask.
Yeah, that's right. Yeah. Catch the bouquet. Have you got one?
Throw it.
Yeah. Talk a little bit.
Right.
Stand up.
You mentioned you were pro CSS in JavaScript, whereas I seem to think that CSS should be kept separate from JavaScript. They're two different things, and you don't want to be like mixing up and making things messy. Why are you pro CSS and JS?
So you're not alone. There's a lot of people that are still kind of on that side of the debate, and it's an active debate that's still happening. So I don't know if one way is better than the other, to be honest, but in my experience, it's kind of the question of how you slice things up. So if you look at, like I started as a Ruby developer, and in a Rails app, you separate things by controllers go here, models go here, and that was kind of the way with the web as well. You got HTML and JavaScript and CSS all completely separated. But the thing is, when you develop a feature, you actually have to touch all three of those areas anyway. And so then the movement to start, like JSX, for example, moves that markup into your component, and now everything's component, it's sliced by component, so all the business logic is related. It's just easier to get to everything. So it's just a different way of slicing it, and it seems to make sense that if you're going to add JavaScript, which is kind of the logic, and HTML, which is kind of the markup, together, you may as well add the styles as well, and that way you're kind of sticking with the component hierarchy all the way down. But it's a debatable topic, so I could be wrong.
You probably don't want to mix and match. But yeah, starting with one all the way down seems like a good idea.
Yeah, it's kind of nice when you're in a React ecosystem at least, because everything is a component at that point. You never have to context switch. It's just, if I want a single focused thing, I make a component and it has a single purpose. And that applies for CSS, even just functionality with no UI at all. Like you can make a component for that now. So it's just kind of fits nicely. But yeah.
Great question.
We're out of time, which is perfect. If you've got any other questions, you can just Slack them directly.
Or just,
offering that
walk up to us.
Yeah. But I'd just like to thank Millie and Steve-O. That was amazing, an amazing first talk.